The year is 1965. The American highway is an arena of high RPM noise. Detroit diesels are screaming at the red line, and the twin-stick transmission is the undisputed king of the road. But in a struggling factory in Hagerstown, Maryland, a quiet heresy was taking shape. An engineering gamble that would rewrite the rulebook of heavy haulage in ways no veteran driver could have predicted. While the world demanded speed, a rogue team of engineers bet everything on a silent revolution. The Maxidyne. Motivated by the threat of bankruptcy and armed with a secret fleet of Learjets known as Bulldog Airlines, this underdog engine snapped axles, defied gravity on the Grapevine, and saved the Bulldog from extinction. But to do it, they had to declare war on the gearshift and prove that noise isn't power. By 1965, Mack Trucks was fighting a war on two fronts. Inside the boardroom, the company was a lone bulldog under siege. While the public saw a legacy brand, corporate raiders saw a bleeding giant ripe for the picking. Rivals like White Motor Company and Chrysler were circling, looking to swallow the independent manufacturer whole. Mack wasn't just fighting for market share, it was fighting for its life. On the highways, the situation was just as grim. The industry was in the middle of a horsepower revolution, and Mack was getting left in the dust. Drivers were flocking to the high-revving two-stroke screamers from Detroit Diesel and the polished muscle of Caterpillar. Those engines made power through speed. To get a heavy load moving, you had to wind them up to 2100 RPM, or let that Detroit scream all the way to 2350 RPM and keep them there. You were shifting gears constantly just to keep the needle in the sweet spot. A Mack Thermodyne, by comparison, was reliable and sturdy, but painfully slow. It was a tractor engine in a world that wanted drag racers. Then came Xenon C.R. Hansen. He wasn't a corporate caretaker. He was a true believer who ran the company with a literal bulldog statue on his desk and a refusal to lose. Hansen knew Mack couldn't win by copying Cat or Detroit. If they built a high RPM screamer, they'd just be a cheap imitation. He needed a secret weapon. He called it Bulldog Airlines, a private fleet of Learjets and helicopters to shuttle engineers and blueprints between Allentown and the plant in Hagerstown. This kept the project off the books and away from corporate red tape. He put the task on Chief Engineer Walter May and the Hagerstown lead, Wynton Pellisoni. May and Pellisoni ran a skunkworks operation that threw out the rulebook of diesel engineering. They didn't want an engine that spun faster. They wanted the ENT 675, an engine that worked harder as it slowed down. They called it constant horsepower. In 1965, that sounded like a lie. In a standard engine, horsepower and RPM are married. When your engine speed drops, your power drops with it. That's why trucks crawl on hills. The engine loses its mechanical edge the slower it turns. May wanted to break that marriage. He wanted an engine that would crank out massive torque as the RPMs dropped, keeping the horsepower line flat even as the engine neared a stall. The wall they hit was airflow. A diesel is just a big air pump. To burn more fuel and create torque at low speeds, you have to jam more air into the cylinders. But turbos need exhaust gas to spin. At low RPM, there's no exhaust flow. The turbo stays lazy, the engine starves for air, and you end up with a stalled truck and a cloud of choking black soot. The Hagerstown team had to force-feed the block while it was barely turning. They developed a specialized fuel system and the tip turbine intercooler fan. This was a small, air-driven turbine that spun a cooling fan to densify the intake air, even when the truck wasn't moving fast enough to catch a breeze. It was built for one reason: to cheat the physics of low-speed combustion. Hansen bet everything on this. In 1967, he even merged with Signal Oil just to get the cash to keep the raiders away while the engineers worked. There was no plan B. When they finally put the prototype, the Maxidyne, on the dyno, the results were staggering. The power curve didn't look like a mountain peak, it looked like a flat table. The engine put out a constant 237 horsepower all the way from 1200 up to 2100 RPM. But the torque was the real shock. Industry standard torque rise was about 15%. The Maxidyne saw a rise of over 50%, hitting 906 pound-feet at just 1,200 RPM. It produced a massive surge of twisting force right where every other engine on Earth would have coughed and died. It behaved like a steam locomotive. The constant horsepower theory worked. They had built the first high-torque rise diesel in history. But as the engineers celebrated, a new problem hit them. The Maxidyne put out so much raw, low-end twisting force that it was a danger to the truck. The transmissions, drive shafts, and axles in the warehouse were built for the old, weaker engines. If a driver dropped the hammer on a Maxidyne through a standard box, the engine wouldn't stall. It would shear the teeth off the gears or snap the axle shafts like toothpicks. They had built a monster, and they didn't have a cage strong enough to hold it. The engine was essentially a wrecking ball. When Mack bolted those first Maxidynes into test chassis, they hit a wall that physics had promised, but their budgets hadn't. That massive low-end torque didn't just move the load, it hunted for the weakest link in the drivetrain and snapped it. In 1966, standard transmissions and axles were built for horsepower, not grunt. They were designed to handle the high RPM spin of a Detroit or a Cummins, where the stress is spread out over thousands of rotations. The Maxidyne, though, delivered a crushing twisting force just above idle. Routine test drives turned into salvage ops. The torque twisted standard drive shafts until they looked like licorice and sheared axle half shafts like they were made of glass. The engine was ready to work, but it was physically tearing the truck to pieces. To save the project, Mack stopped building just an engine and started building a philosophy: the integrated powertrain. They couldn't trust outside suppliers like Spicer or Fuller to build a box that could survive the Maxidyne. They had to build it themselves. The answer was the TRL 107 Maxitorque transmission, later refined into the TRL 1076. This was the industry's first triple countershaft design. Instead of shoving all that twisting force through one main shaft, the Maxitorque split the load across three. It's the mechanical equivalent of having three men lift a heavy beam instead of one. It made the gearbox shorter, lighter, and virtually indestructible. This move toward building everything in-house created a legendary status symbol. Chief Engineer Walter May set a strict hierarchy. If a truck had a Mack engine, Mack transmission, and Mack axles, it was pedigreed and got the gold Bulldog on the hood. If it used vendor parts, it got the chrome Bulldog. But while the gold Bulldog looked good, the transmission itself started a war with the guys Mack needed most: the drivers. Because the Maxidyne stayed in the power from 1,200 to 2,100 RPM, it didn't need a dozen gears. Mack simplified the whole thing down to a single stick with just 5 speeds. Engineering-wise, it was a masterpiece. Culturally, it was an insult. You have to remember the hierarchy of the road back then. Shifting was the ultimate skill check. The Knights of the Road took pride in mastering twin-stick setups, or the new 13-speed splitter, a gymnastics routine where you'd steer with your knees while rowing 2 levers at once to keep the engine singing in a tiny 300 RPM window. Then Mack hands them a 5-speed. It looked like something out of a station wagon. Mack called it a 5-speed, but that deep, low-hole gear gave you enough reduction to crawl 80,000 pounds out of a soft job site without smoking the clutch. To a veteran driver, the Maxidyne wasn't progress, it was a slap in the face. It implied the job was so easy a child could do it. They started calling it a dog, not because of the mascot, but because they thought it was a neutered truck for lazy steering wheel holders. The problem wasn't just ego, it was muscle memory. Early tests were a disaster because drivers couldn't stop themselves from shifting. For decades, they'd been trained that when an engine tone dropped, the truck was about to stall. The sound of a bogging engine triggered a panic response to downshift immediately. But the Maxidyne thrived in the lug. When it hit a hill and the RPMs fell, the fuel pump shoved more fuel into the cylinders and the torque climbed. The truck would dig in and pull harder the slower it went. But the drivers wouldn't let it. As soon as the needle hit 1,500, they'd panic and drop a gear. That sent the RPMs screaming toward the red line, right out of the torque band, killing their momentum and their fuel mileage. The machine wanted to work, but the human kept getting in the way. Mack realized they couldn't just explain this, they had to mandate it. They had to deprogram a generation of men who drove by ear. It got so bad that Mack had to rivet a metal instruction plate, part number 1241, right on the dash. It was a dashboard commandment. Do not downshift until engine speed drops to 1200 RPM. It forced the driver to sit on his hands and wait while the engine grunted at a low, uncomfortable churn. They had to trust the machine wouldn't quit, even though their ears told them it was dying. They hated the silence, they hated the lack of work, and they hated that plate telling them how to drive. But while they were grumbling in the cab, the truck was doing something undeniable on the asphalt. A new legend was being forged, not by speed, but by a relentless, unbreakable will to pull. You had to go to the Tejon Pass in California, better known to truckers as the Grapevine. That 5-mile stretch of asphalt climbs at a punishing 6% grade, and by the late 1960s, it was the unofficial courtroom where horsepower disputes were settled. This is where the Maxidyne had its tortoise and the hare moment. On paper, the contest was a joke. You had the industry standard, a massive Cummins NTC 335 pushing 335 horsepower, mated to a complex 13-speed box. Against it stood the Mack Ent 675, rated at a humble 237 horses with that weird 5-speed stick. In the world of heavy haulage, a 100 horsepower deficit should have been a death sentence. The Cummins driver probably looked at the gold Bulldog on the Mack's hood and assumed he'd leave it in a cloud of soot before the second mile marker. But the physics of momentum tells a different story than the brochure. As the grade steepened, the Cummins did exactly what traditional diesels do. It screamed to the red line, ran out of breath, and forced a shift. Every time that driver hit the clutch, the fuel cut, the exhaust pressure dropped, and the turbo started to spin down. For that split second of shifting, the truck was just coasting against gravity. The driver was frantically working the twin sticks, hunting for a gear to keep the RPMs high enough to stay on boost. It was a sweaty, high-effort battle to stay in the narrow power band. Meanwhile, the Mack driver sat in the right lane, doing almost nothing. He put the truck in fourth at the bottom and left it there. As the grade bit in, the engine didn't choke, it dug in. The RPMs dropped, but the torque rose and the fuel flow increased automatically. The turbo stayed spooled, jamming compressed air into the cylinders. There was no pause for a shift and no loss of momentum. While the Cummins was losing 3 miles per hour with every gear split, the Mack held a steady, relentless pace. By the top of the Grapevine, the weaker Mack had often passed the 335 horsepower giant simply because it never stopped pulling. The Cummins had the peak numbers for the brochure, but the Mack had the area under the curve. It stayed in the fight while the other guy was busy clutching. That victory proved the concept, but it didn't make the drivers like it. They still wanted the noise and the gears, but in 1973 the world forced their hand. The oil embargo hit like a hammer. Diesel went from 27 cents a gallon to over 45 cents, liquid gold almost overnight. Suddenly, operating costs were the only metric that mattered. Fleets staring at bankruptcy started auditing their fuel logs. They noticed something Hansen and May hadn't even led with. The Maxidyne was accidentally a fuel-sipping miracle. The math was simple. A typical Detroit or Cummins struggled to get 4.5 miles per gallon. The Maxidyne was hitting 6.1. Why? Physics. Friction increases with the square of engine speed. An engine screaming at 2100 RPM is fighting itself, wasting energy just to keep the pistons moving. By lugging at 1200 RPM, the Mack cut those internal friction losses to the bone. Plus, by cutting out all that shifting, the truck wasted less energy getting back up to speed. In a low-margin industry, that gap was the difference between staying in business and folding. Then came the final nail. The 55-mile-an-hour speed limit hit in 1974. For Hare engines, this was a disaster. At 55, their gearing put them in a dead zone around 1650 RPM. Too slow for boost, too fast for downshift. They were constantly fighting the truck. The Maxidyne, however, was built for exactly that range. It sat right on its torque peak at 55. The government had effectively mandated the Maxidyne as the national standard. The transmission wars ended right there. It didn't matter if a driver's ego was bruised by a 5-speed stick. The guys signing the paychecks couldn't afford the ego anymore. Mack couldn't build them fast enough. Competitors who had laughed at the low RPM experiment were suddenly tearing down Mack engines to see how they worked. But engineering is a game of trade-offs. You don't get something for nothing. The Maxidyne had mastered going up the mountain, but in their focus on pulling power and fuel economy, the engineers overlooked one thing. What goes up must come down. The very thing that made the engine efficient, low friction and low RPMs, meant it offered zero resistance when gravity took over. Standard engines used high RPM friction to help slow the truck down. The Maxidyne just wanted to roll. The silence under the hood was about to turn from a selling point into a nightmare, because a quiet engine is the last thing you want when you've got 40 tons of cargo pushing you toward a cliff. Gravity doesn't care about your fuel economy, and it certainly doesn't care about your profit margins. While the Maxidyne was printing money for fleet owners on the flat, it was creating a nightmare for drivers staring down a 6% grade. In a traditional rig, you relied on the screaming resistance of the engine to hold back 80,000 pounds of steel. High RPMs create friction and back pressure. It's a natural anchor. But the Maxidyne was designed to live at a lazy, quiet rumble. When a driver crested a pass and lifted his foot, he was met with frightening silence. The low-friction engine offered almost zero resistance. This was the Maxidyne trap. Because of the wide gear spacing, if you crested a hill too fast, you couldn't slow down enough to grab a lower gear. You were stuck in high gear with a freewheeling engine, forced to smoke your wheel brakes just to stay on the road. Mack knew they'd solved the efficiency puzzle, but accidentally broke the safety equation. They rushed out their own engine brake, the Dyno-Retard. The industry standard was the Jake brake, a brutal system that turned the engine into a massive air compressor, putting out 240 braking horsepower. But Jakes worked best at high RPM, exactly where the Maxidyne didn't want to be. The Dyno-Retard was a hydraulic setup built into the valve train. On paper, it was clever. In the real world, it was weak. It relied on engine oil, so when the oil got hot and thin on a long grade, the braking faded. It put out maybe 150 horsepower, barely half of a Jake. Drivers immediately dubbed it the Dyno-Retard. It wasn't just a joke, it was a matter of survival. This resentment sparked a culture war between the shop and the cab. To keep things clean and efficient, the Maxidyne used a puff limiter. This was a little air cylinder on the fuel pump that blocked the fuel rack from opening until the turbo built enough boost. It prevented unburned fuel from exiting the stack as black smoke. It kept the engine clean, efficient, and EPA friendly. But drivers didn't want clean. They wanted throttle response. The limiter's job was to physically pin the fuel rack, stopping it from sliding wide open until the turbo caught up. But the outlaw drivers figured out how to bypass that connection. They ran a line straight from the wet tank, the primary air reservoir, forcing the rack wide open with a constant 100-pound hit of unregulated pressure. This tricked the engine into thinking it had full boost the second they touched the pedal. The result? A thick black plume of soot every time they gear jammed the throttle. Rolling coal wasn't just for show. It was rebellion. It was the driver reclaiming control from the engineers in Allentown. This sabotage came at a price. By killing the puff limiter and winding the Maxidyne out to 2100 RPM to make it sound like an old Detroit, drivers were cooked. They'd bury the throttle and watch the pyrometer needle climb past 1200 degrees, cooking the oil and the metal. The high heat and soot loads blew up turbos at an alarming rate. Managers blamed the engine. Drivers blamed the design. It was a mechanical stalemate. The weirdest part? To the rest of the world, Mack was the hero. In 1978, the movie Convoy turned the Mack RS700L into a global icon. The rubber duck drove a sinister, blacked-out Mack that became the face of the outlaw trucker. But if you listen to that movie, you're hearing a lie. The real Maxidyne, specifically the N676, made a high-pitched pneumatic whine that didn't sound tough enough for Hollywood. It had a signature tea kettle whistle that signaled to everyone in the truck stop exactly what was under your hood. It hummed, it didn't roar. The director made a choice that still bugs purists. They dubbed the sound of a screaming Detroit 8V71 over the Mack footage. The public fell in love with the look of the Bulldog, but they were listening to the sound of the very technology Mack was trying to kill off. Everyone wanted the look, but nobody was ready to let go of the noise and the fury. The industry was in a Wild West phase of engineering, and the chaos couldn't last forever. By the 1980s, the Wild West era of diesel had to grow up. The Maxidyne had proven that low-end grunt was the future, but the hardware needed to get cleaner and tougher. Mack's engineers looked at the plumbing on the early models, specifically that tip turbine system. It was a genius piece of work, but it was complex, expensive, and used active air bleeds that were a pain to maintain. The fix they found didn't just refine the engine, it changed the way American trucks looked forever. The innovation was the Chassis Mountain Charge Air Cooler, CMCAC, or what most of us just call the air-to-air intercooler. When a turbo compresses air, that air gets hot, up to 325 degrees. Hot air is thin and carries less oxygen. Instead of using complex fans or radiator water to cool it down, Mack went passive. They slapped a massive heat exchanger right in front of the radiator to catch the wind hitting the nose of the truck. This dropped intake temps from a scorching 325 degrees down to a cool 110. The change had a physical side effect. To fit that massive cooler, the front grille on the R model and the Superliner had to be raised and squared off. It gave the trucks that tall, muscular snout that every Mack fan knows by heart. Under the hood, this cooler meant the engine burned fuel cleaner and extracted more power without melting pistons. They combined this with the new 4-valve cylinder head, extracting more power from every drop of diesel. Mack rebranded this evolution the Econodyne. It kept the 60s grunt, but added 80s efficiency. The Econodyne ended the debate. For 20 years, Cummins and Detroit had scoffed at the low RPM life, but by the mid-70s they couldn't ignore the fuel math anymore. In a move that proved Zenon Hansen was right all along, Cummins effectively surrendered in 1974. They launched the Formula Series, which did exactly what Mack had done. It choked the governor down from 2100 to 1900 RPM to force fuel economy. The industry had been dragged, kicking and screaming, into Mack's world. The days of shifting at 2300 RPM were dead. But as Mack went global, they found out the Maxidyne wasn't a magic key for every door. Over in the UK, the constant horsepower philosophy hit a wall. American highways are built for locking it into high gear and letting the torque do the work. The UK is a mess of tight roads, roundabouts, and constant stops. British drivers hated the 5-speed box. To hit a roundabout, you need precision. With those wide gear gaps, drivers were always in no man's land. Too fast for third, but too slow for fourth. The engine wanted the lug, but the traffic required a dance. The very thing that made the truck a legend in the States made it a headache in Europe. But down in the southern hemisphere, it was a different story. The Australian Outback was custom built for the Maxidyne. The roads weren't just long, they were endless, unpaved, and brutal. We're talking road trains, one tractor pulling 4 or 5 trailers through soft dirt and sand. In the Outback, momentum is your only friend. If you have to shift while pulling 100 tons through soft sand, you lose your pull and the truck sinks. The Maxidyne's ability to lug down to 1000 RPM without stalling meant Aussie drivers could hold a gear through a soft patch where a Cummins-powered rig would have bogged down. The proof came in 1988. A driver named Plugger Bowden set a world record with a Mack Superliner called the Mack 88. He hauled a staggering 1.1 million pounds, a road train 1,440 feet long through the red dust. The Maxidyne principle worked even when you were pulling a small town's worth of weight. This led to the Mack Titan, a beast built specifically for heavy haulage. It became the backbone of Australian mining and cattle, operating hundreds of miles from the nearest wrench. Mack was at the top of the mountain. They had forced the competition to copy them, conquered the harshest dirt on earth, and built a reputation for being unbreakable. But in the corporate world, that kind of independent success makes you a target. The gold Bulldog was shining, but keeping that shine was about to cost a lot more than just engineering hours. Corporate dominance usually comes with a price. By the late 1970s, Mack was willing to pay it with the blood of its own family. While the engineers were perfecting the low RPM life, the boardroom entered a phase of calculated ruthlessness. This wasn't just about beating rivals like White or International anymore. It was about cannibalizing their own assets to build a new flagship. The victim was the Brockway Motor Company. Mack had owned this New York-based builder for years, letting them produce distinct, rugged trucks known as Huskies. Brockway had a reputation for heavy-duty resilience, and more importantly to Mack's suits, they had a square-jawed, flat radiator look that commanded respect. Mack needed a new high-end model and didn't want to spend years in R&D designing a cooling package from scratch. In a move that still leaves a bitter taste in the mouths of restorers, Mack liquidated Brockway in 1977. They shuttered the factory, fired the men, and raided the parts bin. The flat radiator and hood of the dead Brockway were grafted onto a Mack chassis. The result? The Mack Superliner. It became an instant legend, but that aggressive square-nosed look was born from the ashes of a company Mack deliberately suffocated. Before the accountants completely strangled the shop, the Maxidyne concept had one final thunderous peak, the E9 V8. If the early six-cylinders were about efficiency, the E9 was about absolute, unadulterated violence. This was the constant horsepower philosophy pushed to the edge. A massive 16-liter monster, the E9 wasn't for hauling groceries. It was for the loggers and heavy haulers moving 200,000 pounds up a mountain. In specific tunes, the E9 eventually climbed to 1,000 horsepower, science fiction for the 1980s. But it hit a physical wall: heat. Generating that much low-end grunt created a thermal load that could turn a cab into an oven. It was the dinosaur that signaled the end of the Age of Giants. Magnificent, but too big and too hot to survive tightening standards. In the year 2000, the purebred era officially ended. For decades, Mack had been a sovereign state. They built their own iron, their own gears, and their own axles. But in a global economy, being a loner is financial suicide. Volvo AB acquired Mack, and the shift was inevitable. The unique engineering Xenon Hansen fought for began to dissolve into global platforms. The Maxidyne was replaced by the MP series engine. While a Mack MP8 and a Volvo D13 share the same block, Mack engineers fought to keep the soul alive in the software. They used specific VMAC programming and aggressive cams to mimic the torque rise of the old Maxidyne. They made sure the truck still pulled like a Bulldog, even if the heart was shared with a Viking. But for the old-school mechanics, the arrival of the VMAC electronics meant the end of the screwdriver tune. You couldn't just walk up to the pump and turn up the fuel anymore. For the real aficionados, the signature of this era is the sound of silence. If you're at a truck stop today and hear a high-pitched whirring coming from a parked Mack for 90 seconds after the key is pulled, you're hearing the Centramax. It's a centrifugal oil filter spinning at 5,000 RPM, squeezing soot into a dense cake. It's inside baseball engineering that proves Mack still does things their own way. But the acquisition changed the meaning of the most famous mark on the truck, the Gold Bulldog. For decades, that ornament was certification. Gold meant all Mack, engine, trans, and axles. It was a warning to other drivers that this was a cohesive, integrated machine. Under new ownership, the Gold Bulldog slowly turned from a technical standard into a marketing trim level. As trucks became more computerized and harder to fix with a wrench, a resistance movement formed. Veteran drivers looked at the plastic and sensors and said, "No thanks." They started hunting for old iron. This sparked the rise of the glider kit underground. Operators used a legal loophole to pair a brand new chassis with a mechanical E6 or pre-emissions E7, tuned to that legendary 427 horsepower. They wanted to avoid the EGR and DPF systems that were choking modern rigs. It was here that the spirit of the original Maxidyne found its last sanctuary, a mechanical bunker for guys who refused to let go. But holding on to the past is a fighting retreat. The era of the mechanical miracle is closing, replaced by the era of the algorithm. Ultimately, the Maxidyne proved that in the long war between tradition and physics, physics always wins. Xenon Hansen's gamble didn't just save a company, it predicted the future of the entire industry. The downspeeding engines powering modern Volvo and Daimler fleets today are the direct descendants of that Hagerstown garage project. It turns out Walter May was 50 years ahead of his time. He showed the world that a diesel engine is designed for work, not for noise. The era of the screamer is over, but the legend of the high-torque rise engine lives on every time a modern rig pulls a heavy grade without breaking a sweat. It's a legacy of efficiency, grit, and the stubborn refusal to do things the way they've always been done. Hey, have you ever wrestled with a Dyno-Retard on a steep grade or spent your nights listening to a tip turbine whine? Leave a comment below. We want to hear your real-world war stories from the cab. And if you want more real talk on the machines that built this country, hit that subscribe button.